This video explores the fascinating evolution of modern air conditioning, tracing its journey from simple ice-based cooling to the advanced, energy-efficient systems we rely on today. The technology has transformed significantly over the decades. We moved from large industrial machines using harsh chemicals to the compact, eco-friendly, and highly efficient units that provide comfort in our homes and offices today. This transition marks a journey from early industrial cooling methods to the smart, quiet, and energy-efficient solutions that define our modern standards of living. In the early 1900s, air conditioning was a marvel of engineering. These massive, complex systems were primarily designed for industrial sites and cinemas to control temperature, humidity, air quality, and movement for large crowds. These early centralized systems were far too bulky and expensive for residential use. They were essential engineering achievements that laid the foundation for the indoor climate control we enjoy today. Early refrigeration relied on natural substances like ammonia, sulfur dioxide, and carbon dioxide. While thermodynamically effective, these chemicals presented serious safety and handling challenges. These early refrigerants were common in industrial and commercial settings throughout the late 19th and early 20th centuries, but their toxicity and operational risks were significant drawbacks. Moving away from these early methods was necessary due to severe safety risks, including toxicity, equipment corrosion, and the dangers associated with high-pressure systems. Each early refrigerant had distinct trade-offs. Ammonia offered high efficiency but was toxic and pungent, while sulfur dioxide was highly corrosive and toxic. Despite their effectiveness, the inherent issues with toxicity and handling drove innovation, pushing the industry to develop safer alternatives for cooling technologies. The industry eventually shifted to CFCs and HCFCs. These synthetic refrigerants were non-flammable, had low toxicity, and were chemically stable, making them much safer and easier to handle in widespread applications. This shift was a critical turning point that enabled the mass adoption of air conditioning in homes, offices, and vehicles worldwide by providing a more reliable and practical cooling solution. By replacing hazardous substances with CFCs and later HCFCs, air conditioning became a standard feature of modern daily life, delivering consistent comfort across various environments. The introduction of R12 and R22 marked a significant milestone, prioritizing safety and stability while maintaining the performance required for diverse cooling needs. However, later environmental assessments revealed that CFCs and HCFCs contributed to ozone depletion and climate change. This led to the Montreal Protocol, a global commitment to phase out these substances for a healthier planet. The transition continues as we move toward the next generation of refrigerants, focusing on low global warming potential and high efficiency to meet modern environmental standards. Today, we prioritize HFCs, HFOs, and natural refrigerants like propane or CO2, which offer effective cooling with a significantly reduced impact on our atmosphere. Innovations in compressor technology and smart controls allow these newer, environmentally friendly gases to provide superior cooling while using less electricity. These advancements ensure that comfort is no longer at odds with sustainability, aligning our daily cooling needs with global climate goals. Split air conditioning systems have become a cornerstone of this evolution, offering modularity and ease of installation that traditional ducted systems often lacked. By separating the noisy compressor unit outdoors from the quiet indoor blower, split systems drastically improve comfort and interior aesthetics. This picture shows working of split air conditioner. Refrigeration cycle is also described in this slide. This design flexibility allows for targeted cooling, meaning you can cool only the rooms in use, further optimizing energy consumption and lowering utility costs. Modern split units also feature advanced air filtration and smart sensors, maintaining not just the temperature, but also the air quality of your home. The shift toward these systems reflects a broader trend of decentralized and personalized climate control in our living and working spaces. We are now moving toward inverter technology, which adjusts the motor speed to maintain precise temperatures, eliminating the energy-wasting cycles of older, on-off systems. This evolution represents a commitment to both individual comfort and a collective responsibility to reduce our environmental footprint. As we look ahead, the integration of renewable energy and further innovations in refrigerant chemistry will continue to shape the future of cooling. The goal remains clear: to provide reliable, efficient, and sustainable climate control that protects both our comfort and our planet's future. By understanding the history and the ongoing innovations in this field, we can make informed choices about the cooling systems we install in our own homes. Thank you for joining this look at the history and future of air conditioning. Together, we are creating a cooler, more sustainable world for everyone. Maintenance is key to ensuring your air conditioning system continues to perform at its peak. Regular care not only extends the lifespan of your unit, but also keeps your energy bills in check. One of the simplest and most effective steps you can take is to regularly clean or replace your air filters. A clean filter allows for better airflow, making your system more efficient. Blocked or dirty filters force your air conditioner to work significantly harder than necessary, which can lead to increased energy consumption and premature wear on internal components. It is also essential to keep the outdoor compressor unit free from debris, like leaves, dirt, and overgrown vegetation, which can obstruct the airflow needed for cooling. Maintaining adequate space around your outdoor unit ensures it can properly vent heat, which is vital for the overall efficiency of the entire refrigeration cycle. Professional servicing is recommended at least once a year. A technician can check refrigerant levels, inspect electrical connections, and ensure all parts are operating correctly. These inspections can catch minor issues before they become expensive repairs, ensuring your system remains safe and reliable throughout the hot summer months. Keeping your thermostat settings optimized can also make a big difference. Programmable or smart thermostats help you manage your cooling usage more intelligently. By adjusting temperatures when you are away from home, you can save energy without sacrificing comfort, making your cooling strategy both smart and efficient. Consider the age of your system as well. If your air conditioner is over a decade old, it may be significantly less efficient than modern models, leading to higher long-term costs. Upgrading to a new, high-efficiency unit can offer substantial savings on utility bills and provide better climate control compared to older, aging equipment. Always look for ENERGY STAR ratings or similar efficiency certifications when shopping for a new air conditioning system to ensure you are getting the best performance. By combining proper maintenance with modern technology, you can enjoy a comfortable, reliable, and energy-efficient home environment for years to come.